All right. So we're going to draw. We're going to do it twice. We're going to draw our formula triangles. So these are the generic 45, 45, 90 triangles. So in a 45, 45, 90, each of the corners is 45 degrees. Each of the short sides is x. They're the same, whatever they are, whether it's 2 or 7 or 500, are going to be x. And then the hypotenuse is always x times the square root of 2. Now remember that because 90, we get 90 because it's 45 times 2. We are now going to put together, here's the work, here's the final. Okay, we're going to put together the sine of 45 degrees. And if we remember our SOHCAHTOA, we're going to write it up here. SOHCAHTOA. So is our sine function. S is for sine. O is for the opposite. And H is for the hypotenuse. So when we say so, we mean sine and we mean opposite over hypotenuse. So the sine of 45 degrees is a fraction. Remember, trigonometry is not scary. It just tells you which fractions you're putting together. It's the opposite side, x, over the hypotenuse, x times the square root of 2. This makes my life happy. I have an x on the top and an x on the bottom. They cancel each other out and it becomes 1. The only sad part is that root 2 on the bottom. Some of you guys are giving me the same strategy you give your parents when they ask you to do something. You just ignore them and pretend like you don't hear them until they stop asking you, and then you're out of it. I'm a mom. I have kids that do that exact same thing. And then when I yell at them the next day, why did you do that? They're like, I didn't hear you. I'm a liar.
Are you sure it's June 85th? I don't think it's June 85th. I think there's something wrong about that.
So, some of you guys have been ignoring the root on the bottom part of this packet and hoping that it just goes away. But here it is again. It's going to be a reoccurring theme this entire section, so let's just emotionally invest ourselves in fussing with it now. When you have a root on the bottom, you multiply both the top and the bottom by whatever that root is. So I'm going to multiply the top by root 2 and the bottom by root 2. So now my final answer is going to be 1 times the square root of 2, which is just the square root of 2, and square root of 2 times the square root of 2. Which square root of 2 times square root of 2 is square root of 4, and that's equal to 2. So here's a beautiful thing. Hunter, you're going to miss my beautiful thing. Here's our beautiful thing. It doesn't matter how big. We can have a 45, 45, 90 triangle the size of this room, or it could be small enough it fits on a pinhead.
Whoa.
It will always have a sign that's equal to root 2 over 2. Always.
If it's a triangle?
If it's a 45, 45, 90 triangle, the sine of that 45 degrees is always going to be root 2 over 2. Doesn't matter how big or how small it is. It's always going to be that number. Let's see what the cosine shapes up to be. So cosine of 45 degrees, and cosine is opposite over hypotenuse. It's the ka. And just to let you know, when because I can't whistle when I need to call my people back to me, like in a crowded room, I always cuckoo, cuckoo, and they know to caw back and we identify each other because I can't whistle. So this is the caw, 45, 45. Cosine is adjacent, which is the one that runs into the 45-degree angle, but is not the hypotenuse. For us, that's x, over the hypotenuse, which is x root 2. Give me a thumbs up if you can see that sine and cosine are the same thing for a 45, 45, 90 triangle. Give me a thumbs up if you can see that. The cosine of 45 degrees is x over x root 2, and the sine of 45 degrees was also x over x root 2. So our final answer, after we cross the x out and multiply by root 2 over 2, is also going to be square root of 2 over 2. For every 45, 45, 90 triangle. All the 45, 45, 90s that are giant big boys and all the ones that are teeny, teeny babies and everybody in between, they are all root 2 over 2. All right, last one is my tan. He spends a lot of time out in the sun. He's tangent. Just kidding. Tangent is the opposite side over the adjacent side. Opposite side is x. Adjacent side is also x. X divided by x, show me, is what number? X divided by x is 1. It's a number. I try to give you a hint.
X squared.
Divided. So if x were 3, what's 3 divided by 3? If x were 7, what's 7 divided by 7?
X.
Oh, wait,
You
no.
know, it's a variable.
If x were 10, what's 10 divided by 10?
1.
1. So the answer to this one is always 1. Okay, let's draw some lines so we can keep track. Okay, so sine of 45 degrees is root 2 over 2. Cosine of 45 degrees is root 2 over 2. And the tangent of 45 degrees is 1. Always. So on your test, I'm going to ask you, what's the cosine of 45 degrees? You don't even have to draw a triangle. You have your note packet. You'll be able to use it on the test, so just flip to this page and look it up.
And when they answer that, they'll just answer root 2 over 2.
Mm-hmm. Yeah, and this isn't a work problem.
Right, that's what I mean.
Yeah. All right. 30, 60, 90.
What?
Find the trigonometric ratios for 30, 60, 90. I have to erase this because my giant handwriting is in the way. Does everybody have this down?
Yeah. I wrote just as giant and lost for space.
No.
Okay.
It's a really weird whistle, dude.
Wait, I don't do that.
It was.
Okay.
I thought you said it would. This is really getting noisy.
Okay, guys, got another one to do here.
So now we're going to do the 30 degrees for a 30, 60, 90. So let's draw our triangle.
Are we still
So this
recording?
guy is 30. This guy is 60. Short side gets to be called x. Long side gets to be 2x. Remember, he's the big brother. So he gets everything that he wants. It's twice as much as anybody else. And then the middle, the medium side, gets that doggone root 3, all ugly, irrational, and terrible. I don't have anything against, don't have any baggage or anything.
Very fast.
Okay, so we want to find the sine of 30 degrees. That little Sorry, I didn't give you a bunch of space. Squeeze it in. If you guys need to put it on the front of your packet in this little spot, put it wherever you need to. Okay, so the sine of 30 degrees. Here's our 30. See how it matches this 30? Sine of 30. I'm going to pause for a moment so that you guys, I need to double check that you all have this written down. So, next to the x, scratch my face.
Oh, you got yourself in the face.
Hey guys,
Next to the x, you guys are going to put opposite. O-P-P. Yeah, you know me.
You told me.
The next to the 2x, you're going to put height to stand for hypotenuse. And then next to the x root 3, you guys are going to put adjacent, A-D-J. So now we know who the opposite side is, who the hypotenuse is, and who the adjacent side is. So the sine of 30 degrees, sine is opposite over hypotenuse. Next to the x is the opposite side. Opposite
I already did it.
over the hypotenuse.
Oh wait, no, I didn't.
So the opposite side over the hypotenuse.
you guys need to be writing this down.
Are you sure?
So I have one x on the top, I have two x's on the bottom. Ethan?
So, do you have to do it? Do you have to find a sin for both 60 and 30?
They're going to be different.
Okay.
So in this problem we don't. But if they ask for sine of 60, you're going to have to do this problem.
Okay. Oh, it's because you're only doing 30 because it says specifically 30. Oh, okay, I got you.
Okay.
Are you writing?
1x divided by 2x's.
Where's this?
1x divided by 2x's is equal to 1/2. 1x divided by 2x is equal to 1/2.
Is that it?
Yeah, that's it. The answer is 1/2. The answer, Braden and Hunter, one of you guys Rochambeau, figure out who's not going to sit next to each other.
And that is.
And then Jose, you're here as a gift, so make sure that Hunter's not Braden doesn't
Thank you.
get you in trouble.
We're over here. Right now, you're really annoying.
You started that. Right here. Work. Under the work.
So the cosine, it's the ka part of our equation. It's adjacent over hypotenuse. The adjacent side is x root 3. And the hypotenuse is 2x. And I breathe a sigh of relief that we don't have a square root on the bottom. Because now we don't have to do the timesing by the root. X on the top and an X on the bottom leave us with 1s. So we just have a root 3 on the top and a 2 on the bottom.
Why wouldn't it be 1 root 3?
If you want to write a 1 there, that's completely fine.
Is there
It's
always
for
an
the-
invisible 1 there?
It's for the same reason we don't write 1x.
Oh.
It's implied.
Oh,
There's
I-
just, if it's hanging out by itself, we don't write the 1 down.
Oh, I didn't even know that the square roots did that.
Square roots, we treat square roots the same as usually an x. The same rules apply. If you're adding a root 3 plus a root 3, you end up with 2 root 3s. Kind of like an x.
Oh, yeah, okay. That makes sense.
Okay. Tangent of 30 degrees. Tangent is the TOA. It's the O and the H. The opposite and the hypotenuse. Opposite. Sorry, not over, opposite over adjacent. Sorry. Opposite, sorry, TOA. OA. Opposite over adjacent. So the x's cancel out. We get a 1. And we have a square root of 3 on the bottom. So we have to multiply the top and the bottom by square root of 3. It's whatever's down there, it's whatever's under the root, we have to multiply by.
Why do you have to do that?
It's rationalized in the denominator. It's a slide rule. And it gets all the irrational numbers out of the denominator and into the top.
That is amazing.
So the top gets to be square root of 3, and the bottom gets to be 3, because the square root of 9 is 3. So this is true for every tangent of 30. So in every 30, 60, 90 triangle, the tangent is always going to be root 3 over 3. In every 30, 60, 90 triangle, the cosine is always going to be root 3 over 2. The sine is always going to be 1/2. Back in the ancient days when I went to school here, we didn't have calculators. And we would have to do trigonometry by looking it up in a table in the back of the book. So your geometry book literally has a table in the back with every angle from...
So it has the answer?
yes, but it takes...
That's not fair.
You have to look them up. So if I wanted to find... So in the back of the book, there's your trig tables. Under the reference section. Because that's also an old thing back from the ancient days when I didn't have. From the ancient days when you had to look it up and you didn't have calculators.
Yeah.
Okay. So you guys, let's take a look at example 3. You guys will love these examples. I'm going to pause so that you guys can get calculators. Okay, on example 3, I want you to circle the 28 degrees. Next to D, I want you to write hypotenuse. again, is 14 right next to the 28 degrees or opposite of it? Opposite. So I want you to write OPP right next to the 14. Which trig function uses opposite and hypotenuse? Sine. Sine of 28 degrees. Piper, you guys are gonna miss it.
Circling and writing all this, you need to be doing that. For the test.
Sine of 28 degrees. We picked sine because sine is the one that deals with opposite and hypotenuse.
0.469.
Sine of 28 degrees is equal to 14 over d. Now, those of you guys that loved the beginning of chapter 7, I have a great gift for you.
What do we do then?
You're not gonna change anything. You're just gonna underline sine of 28 degrees, and you're gonna put a 1 underneath it. And now we're gonna cross multiply to solve for d.
14.
So we're gonna go 14 times 1. And d times the sine of 28 degrees. Ethan already put in his calculator sine of 28 degrees. And what is it without rounding, Ethan?
0.469.
Keep going.
0.469471568.
Okay, because I don't want to write all those giant numbers on my paper while I'm doing my work, I'm going to keep it sine of 28. But in my head, I know it's just a decimal number. Uh-huh.
We're doing it right. Maybe this is exactly.
What? You calling me out, Miss Mines? Tell me.
It's 26.
Sine of 28? Yeah, that's right.
Yeah. It's not.
I got
Okay.
it's word for that.
It's the
Oh,
My calculator is dumb.
Okay, we're going to wrap this up. We've got 2 minutes. You guys going to miss it. Stop talking. Sine of 28 degrees. We're going to divide both sides by the sine of 28 degrees. In your calculator, you're going to put 14. You're going to put divided by. You're going to put sine of 28. That's what goes in your calculator.
29.8.
And I think we're going to round to the nearest tenth on this.
So
we're going to go 14 divided by the sine of 28. I have to put 28 in first because that's. So we get 29.8. So D is approximately equal to 29.8.
nearest.
Okay, I'm going to do B real quick. If you don't keep up, I'm going to go over it again tomorrow.
Cool.
We have 18 degrees. We have the hypotenuse and the adjacent. The trig function that deals with hypotenuse and the adjacent is cosine. Cosine of 18 degrees is the adjacent side over the hypotenuse. We're going to underline cosine of 18 and put a 1 underneath it. Then we're going to cross multiply. 1 times x is x. And then we get 42 times the cosine of 18. Put that in your calculator. 42 times the cosine.
39.9.
Let's round to the nearest tenth and say 39.9.
Done did. Done diddly do.
And that's how you use trigonometry in any triangle, not just special, in any right triangle, not just special triangles.
Mas ei.